Good morning. Welcome to TMMS Productions. This is the second video of the series in which we will be solving problems based on arithmetic progression. Let us look at the first question. An AP consists of 50 terms. If the first and the last terms are 8 and 106 respectively, find the 21st term. We know the number of terms, that becomes n. We know the first and the last term. So first term is your A, which is A1, which is equal to 8. And the last term is equal to 106. Now, the last term becomes which one? 50th term. So this becomes A50. Now, what do we want? We want the 21st term. So, 21st term is A21 and that is what we have to find. Now, if I have to find nth term, I use the formula An is equal to A plus n minus 1 into D. Now, in order to find A 21st, that means 21st term, I'll need A and I'll need D. And n will be 21. So, when we write this formula, we know the value of A, which is 8, but we do not know this value of D. How do we find this D? By using this information. And we are going to use the same formula, but we will write A50, which means what? 50th term. And 50th term will be A plus 49D. How does it become 49? 50 minus 1. And so we have to substitute A50 as 106, and that is equal to 8 plus 49D. And so 106 minus 8 is equal to 49D. And so 98 will be equal to 49D. And that gives us D equal to 98 upon 49, which is equal to 2. Now, we have to find A21. So A21, using this formula, it will become A plus 21 minus 1, that is 20D. And so we know the value of A, which is 8, plus 20 into bracket D is how much? 2. And so we have 8 plus 40, which is equal to 48, and that is our 21st term. And that is our answer. Come to question number 2. How many whole numbers, each divisible by 11, lie between 100 and 500? Now in this, understand that we have these numbers, each divisible by 11. So it means that D, which is the common difference, that will be equal to 11. Now, these multiples of 11 lie between 100 and 500, which means the first term should be more than 100. So now we will show a little bit of rough work here. 100 divided by 11 will be 11 9s 99 and 1 upon 11, which means the 9th multiple is less than 100, so the 10th multiple will be more than 100. So we will say A1 will be equal to 11 into 10, which will be 110. And the last term should be less than 500, so we will show 500 upon 11. 11 4s 44. 11 5 is 55 and 5 upon 11. So the 45th multiple is going to be less than 500. So my AN or the last term will be 45 multiplied by 11, which will be 495. So we know that first term A, which is A1, is 110, and the last term, which is AN, is equal to 495. And so we have to find the value of n in order to get how many whole numbers are there between 100 and 500. We already know the common difference. So all we do is use the formula AN is equal to A plus n minus 1 into D. And for AN we will write 495 because that is the last term of this series. A will be the first term, which is 110, plus n minus 1 into D is 11. And so we will have 495 minus 110 equal to 11 into bracket n minus 1. This term we wrote here. And so when we subtract, we will have like so. And so we will have n minus 1 will be equal to 385 upon 11. So 11 goes 3 times and then 5 times. And so n will be equal to 35. This one comes that side. So plus 1, which is equal to 36. And so there are 36 terms which will satisfy the condition. And that is our answer. Let us come to question 3. Insert 5 numbers between 12 and 42 so that the sequence is in AP. Now out here, first term becomes 12 and the last term becomes 42. And so we will write these numbers as A1, which is equal to 12, and AL or the AN will be equal to 42. Let me put it this way. And so our first term will be 12, then the second term will be A2, then A3, then A4, then A5, and then A6. These are the 5 terms that are to be inserted between 12 and 42. So we see first term here, last term here, and in between we have 1, 2, 3, 4, 5 terms. And so we can actually see that our 42 is AN. What is this? This is AN, which is A7. So we will say A7, that means 7th term is 42. And now since AN, that is nth term, is A plus n minus 1 into D, therefore A7 will be equal to A plus 6D. Now A plus 60, A value we already know. How much is it? It is 12 plus 6D. Do we know the 7th term? Yes, that is 42. And so we will have 42 minus 12 is equal to 6D. And so 30 equal to 6D. And our D will be equal to 30 upon 6, which is equal to 5. So now that we know that value of D is 5, value of A is 12, we can actually find the terms which are to be inserted. A2 will be A plus D, which will be equal to 12 plus 5, which is 17. A3 will be equal to A plus 2D. Which formula have we used? This one. This tells us the general term, and we use this formula to get A plus 2D, and that is 12 plus 2 into 5 means what? 10, and that will be giving us 22. Let us come to A4. Then we'll come to A5. Then we come to A6. Now pause this video. Get the values. Let's check it out. A plus 3D. So that is 12 plus 5 3s 15, which is 27. A5 is A plus 4D, which is 12 plus 5 4s 20, which is 32. Next one is A plus 5D, which will be equal to 12 plus, which is equal to, and so we will say, therefore, the 5 numbers are 17, 22, 27, 32, 37, and that is our answer. Hope you have understood how to solve such problems on arithmetic progression. Thank you for watching.